Okay, so hello everyone. So at this point, um, I'm making a video for ME 2030 students on assembling their flashlight parts. So I hope at this point you have your flashlight base, the head, the window, and even the O-ring for your flashlight. And what we're going to do is we're going to assemble all of those parts. So we have SolidWorks loaded up. We're going to go up into a new file. So before we've been working on this part file, so that meant that there was no relative motion of anything within the part. But now we can begin to assemble different parts together, which offers the opportunity to have relative motion or different materials, or can be taken apart and put together. So we're going to start with an assembly now. Okay. So this is going to, while this fires up, it's going to open up the option for what part files do we want to bring in. So it's really important. It's really important that you keep all of your part files together. So, and your assembly. So, for example, on my desktop, I have something called flashlight parts, and I have the 4 parts that I need. And the reason that this is really important to keep all of these parts together is that whenever you open the assembly, if you don't have these parts in the same location that it was before, for example, you might come to a computer on campus, or you move the files. The assembly is not going to be able to find them, and it's not going to be able to build your assembly because this assembly file will reference all of these parts. So you can select multiple parts. Either right now I'm holding Control and then selecting different ones, or unselecting, or you can always just click the top one and hold Shift and click on the bottom, and it'll do everything in between. Shift and it'll do everything in between. So let's pretend like we missed one just in case, so we show you how to do that. So I'm going to select multiple right now and hit open. Okay, and it's going to allow me to start to place each individual one. So I can place the base, I can place the head, I can place my O-ring. Okay, so when you bring them in, you'll notice that the first thing you bring in will be fixed. And so if you right click on it, you'll see you have the option to make it float, and so you could then move it around in space. So, but it's usually nice to have one thing that's fixed, and then you'll essentially say how all of these other pieces will go together. So these two can move around, and they're not there yet. So let's say we forgot our window, right? So we need to go back, and you also do insert component here. And so sometimes it'll auto come up. You might have to hit browse, it'll do the same thing. So let's go, and we forgot our window. So I'm going to select the window. I'm going to open my window, and it's going to allow me to place it. And you'll see that the 4 parts are in here, and you can see you have the planes for each one of the parts that you had, as long as all of the features that you made in the part that you can edit. So they're linked. So you can change something here, and it'll change something in your part, or if you change something in your part, it'll update it. It'll update it here. So the first thing I want to do is I'm going to put my window inside of my flashlight head. So I mean, you can always just drag things around, right? But we want to define where they are, more precise than that. So for example, I want this surface to be in contact with the surface on the bottom. So you're gonna have to get good when you're doing assembly, pushing down on the scroll wheel and rotating, or zooming in and out, or you can also hold Control and push down on the scroll wheel and move around. So those are common things. So, and how you define things relative to each other is called a mate. So under the assembly tab, you're going to have a mate. So what I'm going to do is I'm going to say I want this surface, and I'm going to rotate down, and this surface to be coincident. So what coincident means that they're touching, basically, or they're on the same plane, basically. So you could have parallel, where they're parallel but far away from each other, or you could have perpendicular. So usually when you select 2 things, it usually can recognize what you want. So for example, so I didn't need to hit coincident first, although I could have. But when I selected those 2, it knew, okay, if you pick 2 planes, you probably want them to be coincident. So it kind of auto highlights that. So I hit OK. So So keep in mind, it keeps me in the mates, so I can continue to do more mates if I'd like. Um, uh, so if you want to go and do something else, though, make sure you exit out. Okay, so at this point, the window, it now floats on the top surface of the head, but it's not stuck inside of it. So what now I have to do is I have to say, well, I think this surface right here, so I might have to zoom in. Sometimes I notice this when something's clear, it has trouble selecting it first. So then I'll just go and I'll select the other one first because the order doesn't really matter. This surface here and this surface here, I also want those to be coincident. So I'm going to hit check mark. And I also, so now it's free to move in these directions. And so I need to define that, right? So I'm going to say, okay, well, I want this face. Notice how I have to rotate around and that face. And notice how I was clicking faces to be coincident, right? So I was not clicking, so like here's a line, here's a face, and you could also get the midpoint, right? So there's faces, you know, lines, and there's points. So keep in mind that all of those will do different things. So let's exit out now. So let's see now. So now you'll see that our window in our head is fully constrained. One issue you might notice is that because we made the window slightly smaller, it's kind of offset into this corner. So if we want it to sit in the middle, we can go into our mates here, so we can do this little drop down tree, and go left click and go to the edit feature. And we could say, you know what, actually we want a little bit of offset here. So I'll do 0.01. And you see that offset. And if it's in the wrong direction, you can always do flip, but we're in the right direction to begin with. So I had to hit this and then I could put it in there. So hit check. And then I'm going to close the mate, and I have to go to this one. You'll see how it changes now to a distance instead of coincident, but it's similar. It's a coincident with an offset distance. So I'm going to open up the offset, do 0.01, and it's going to move it over here, and I'm going to hit check. So now you'll see now it's lined up with a little bit of gap around the edge, right? So that's where the window is going to be, and then we're going to bolt it down. All right, so after we got that, next we need to put the O-ring onto the top here, and the O-ring is going to come and sit on this surface right here. So what you'll notice that the O-ring, when you try and mate it, since the O-ring has one surface, this one kind of complicated round surface, if you click on these two and say, oh, I want those two to be together, what you'll notice is it's not really doesn't really constrain anything that we want. It basically just move around in space. So we don't really need this. So when you have a complicated part like this, we're actually going to have to mate some of its base planes to some of either the features here or the base planes on this. So I'll show you how to do that. So I'm going to mate, and instead of selecting a surface to mate, I can bring down this drop down menu, which gives me all my parts, and I can go to my O-ring. And inside my O-ring, I have some of the base planes. So I have 3 base planes, and for example, this front plane, I can say, oh, well, that front plane, I want that to sit on this surface right here. And we're going to need to offset this by the radius of the cross section of this O-ring. So that looks good, right? And it looks like it offset it in the right direction. So I'm going to hit check. And so when we go and look up now, you'll notice it moves in the plane, but now we got to get the ring over the top basically. So the next thing we can do is we can say, well, we want maybe this top plane. We're going to line it up with the plane of our base. So our base also has, so maybe we'll zoom out, has a front plane, and we can line those two up. So that'll at least get it in one direction, right? So now it's just going to move forward and back, but it can't go the other direction. So we just got to get this last direction. So the last direction was for I'm going to come down into the O-ring, and it's this right plane. And keep in mind, it's not always right and right. So, but it just happened to be on this one. So it might be different on yours, right? And you'll notice this one is not really lined up right. Oops. So what I'm going to have to do is I'm going to have to offset this by the radius going to the outer diameter here. So I think that's 0.1. And that'll line it up right on top. So we'll hit check. right? And then I can get out of my mates. And you'll see now I have my O-ring sitting where I want, and I have my head here. So the next step will be to get the head on top. So let me pause this real quick. Okay, so one thing you should always do when working with Solidworks or any program is really save repeatedly, right? Just because it will crash on occasion. So if it requires you to rebuild, I'll just hit rebuild, and then I'll just save this as my flash assembly. Save. So let's say I wanted to modify something, one of these. For example, maybe I will get rid of this coincident. You can right click and hit delete. Yes. You can delete one of these. Delete. Yes. So right now, so we deleted a couple of these, right? So now it's going to stay along this back plane. They'll always be even, but otherwise it can move. So one thing that can happen when we left click and edit it, sometimes, for example, here we have it in the right direction. Sometimes when you make it, it'll actually be in the wrong direction. So you actually have this mate alignment. So for example, if you wanted to, align that way instead, you can switch it with this mate alignment. So if it's wrong, use this mate alignment. And there's also, so last time you saw we did three, made this window inside of here, we did 3 mates. You could also potentially, instead of mating faces, you could mate lines basically. So instead of mating, for example, let's move this out of the way. So instead of mating this face here, we could also just mate this line down at the bottom. We could say, oh, we want that line to intersect with this line, right? And so you can do that, and then we can click check. And at this point, then this can still move around, and we could also just say we want, let's go to the solid first. We want this line to be coincident with that line as well. And we could do our offset 0.01. Right, so we could offset those two lines, and then click check. So now you can see we did this mate with 2 of them. Maybe we so those, maybe we also want to set the distance on this one so that we get it right. So we'll offset it 0.01. Right. So now we have it lined up, and it's sitting inside that space there. So that looks good. So at this point, I prefer the three method. It's a little bit simpler, but there's multiple ways to do it. So right now we're going to get back to putting this on top of here. So to do that, what I'm going to do is I'm going to take the head and I'll right click on it, and I can make this transparent. I can completely hide it, but I'm just going to make it transparent. That way I can see more of the surfaces that I'm working with. So what I'm going to do now is I have to tell it, 1, the height, what height it should sit at, and 2, that it should be concentric. So first, I'm going to say that this cylinder is outer cylinder, and don't select the conical portion. That's the only thing you can't select. You have to select some line or this surface, and you have to collect, like this line. We might say those two, we want those two to be concentric, right? So I'll click check. What that'll basically do is that allows this to move up and down on top of there. And now we just need to say the height. So this is kind of hard. We're going to have to zoom in and select this face with this face. We can put those two and offset them by a little bit. One thing you'll notice is if you, instead of selecting the faces, won't let you move it unless you have nothing selected. Let's say instead we had selected, the edge here instead of this face underneath the ring. Say we selected the edge, and then we came up here and selected this face. You'll notice that because we selected an edge, the offset is no longer available. So you need to select two faces to be able to do that. Let's see if it'll let us select it. There you go. So then now we can offset it. And we can offset it by the thickness of the O-ring, right? Because this top head is going to come and sit down on top of this O-ring. So you can see now, this surface right here is going to come, it's going to squish down on the O-ring. And that means when you tighten it down, you're going to squish down, and this will kind of keep the flashlight from being loose, but also not pushing too hard. Pushing too hard down, there'll be a light bulb here contacting the top of the battery. All right. The only thing now is this can rotate. So if you don't like this thing rotating, and you also notice that this thing can also rotate because there's different ways those can be offset by 0.01 while those two lines are there. So let's do the last mate in here. So if we simplify these two and just not make them 0.0, 0.01, 0, so just turn off the offset. And then we come into this one. So that was this one, edit feature. So we don't want any offset. We want them just to be coincident. That'll lock it back down. So I do like to do the other one. I do like to just do the faces rather than these, because you can see here, because we did an offset, there's a couple different ways where it wasn't completely constrained. But let's say you didn't need the offset, then you could just do the lines basically, and that would be lined up. So right now it's fully constrained, but we don't quite have the gap. So either way is fine. I mean, it's designed so that it'll still work, right? So just maybe not quite right in the center. So next, what we want to do is we want to put in our fasteners in here. So we can just grab the fasteners. Oh, I forgot the one thing I was going to show you. So this thing still rotates, right? So if you want this to not be able to rotate, you can always mate like one of these faces, like maybe this face, and you could mate it with one of the planes just in the these like kind of base planes in your assembly. So now those two planes are perpendicular. So now you'll see that this will be unable to rotate and it's fully defined. So a couple options we have, we can pull in fasteners. We can go into our design library and our toolbox. Go to ANSI, go to bolts and screws. So you can see our ANSI, bolts and screws. And next we're just going to choose the machine screws, because this is going to be just a number 1032. Then we can right click on this and do create part, and that'll allow us to configure it. Should still be going. It appears a little slow while recording. And you see it has the size, and we want a 1032. 1/4 inch long is good, so I'll just hit check. And I've noticed on some people's, it will actually put the screw over here. You'll be able to find it. And sometimes you have to do right click, insert into assembly, and then that'll put it actually into the assembly right here. So I'll just do check. And I can do right click, insert into assembly. And it's going to put another one right on top. And you could even change it now if you wanted and do check. So these aren't constrained anywhere, so we'll have 2. And then the other one we need is we need to go up a certain type. So we're in bolt and screws. We go back into bolt and screws. We need the set screw. So we have a set screw with a socket drive. So this one we can insert into assembly. And we're going to want the 1032 and 1/8. So if it's not selected there, select that one. And the drive type, we're going to want a hex. Click check. Hopefully it's underneath here. So there's the last one. So there's the 3 fasteners we're going to need to put this all together. So what I'm going to do now is I'm going to come in, I'm going to say, well, I want this barrel to be concentric with that barrel. So when we made it, not insert, we're going to insert this, and we're going to have it be concentric with that surface, right? And it's facing the right direction, so I'll hit check. And now I need to pull this up. It's not that low, so you see now it slides up and down. And the head on this is actually a little bit bigger than the one we're using. This to be coincident with that, and we'll hit check. And we can want this to be coincident with this, so that's good. And then we want this surface. If we can't select it, what we can do is, whoops, that, check. And then we need this surface to go inside of here, so I'm going to rotate it so I can face it and click on the inside. And you can see right now it's backwards, right? So what I'm going to have to do is scroll down and do the flip it. Sometimes it doesn't look quite right because it's way out here. So I'm going to go out so I can zoom in now. And so this, right, obviously it's going to be, closer to here or something, right? So what we're going to do is we're going to mate so we can't select it, zoom in. I want this face and this face. And we can offset those, right? So now they're equal. And we want to flip that direction, right? We want it to go in. Maybe we'll just do maybe like 0.13. Let's check that. It's just going to sit maybe a little more, 0.15. So we actually just tighten it down in there so it's not exact. So it sticks just slightly into the hole, and that's fine. Okay. So now we have, this is our assembly. So another way to get fasteners is you can go online and you can go to McMaster, and what you can do is you can search for your fastener. So for example, I want 1032 handhead screw, right? So here's the 1032. 1032 on the thread size. It might not be this material, but so maybe it's this one right here. It's this 1032 stainless steel screw that I'm going to buy. So you can go and find anything you want, but just for the purpose here, and pick it. And you can now, McMaster will have a Solidworks model. And you can do this for pretty much any other parts. Alright, so you can see they've made this part. So I can do save as, and I could save that into the flashlight parts. This is their part number. I'll update to the current version. then when we come here, back into our assembly, Solidworks sometimes is a little bit funky about trying to get into, so you can always minimize this here. So we behind it, sometimes it's a little funky about that. And we could then, if you wanted to, instead, you could browse, and we could pick this panhead screw. Alright, so we could bring that in instead, for example. And this one, but you can always make more of them if you want. So just copy and paste, we'll make another one. So these ones you can see it shows some of their, if you look inside of them, it's showing some of their sketches. So you could always select these and just say yes, it looks like you have to select them one by one. You could hide the various. So sometimes if the sketches aren't something being used, for example, like these sketches, sometimes it'll show them. So you can start to delete these different things. So we've deleted most of it. Split line. Looks like just one of these revolves. We can still see the sketch. So we'll hide that. Alright, so you can see, you can kind of go through and find the different things you want to hide. This looks like something like a helix, right? So this was probably this helix spiral sketch. So we can hide that. Oh, no, it's not that one. Maybe it's this revolve sketch. No. Oh, there's two helix spirals. There you go. It's actually this sweep. So we'll hide this one. So sometimes it takes a little bit of work. And when you make your parts, you can decide whether to do them or not. And you could do something similar as we could line up this head. So let's just delete this, and it's going to want to delete everything else. So let's say yes. So we could make this fastener. Let's say, oh, this flat surface and this flat surface are parallel. It's good. And then we could say, this part is round, and we could say, oh, well, this part and this part are going to be coincident, right? So it doesn't even need to be something on the bottom necessarily. Now we have our screw in there. Alright, so there you have it. Again, F will fit it to the screen. So the one other thing that can be helpful when doing assemblies is the exploded view. So under assembly, if you come to exploded view, you can, usually I'll zoom out then, you can then select the part and then move them up, how they would go together. So you might take that out. Whoops. Oh, one. Sorry, let's do exploded view. So you got to click it and then pull up in the direction, and then you need to right click to confirm that part and then come and do the next part. Otherwise it'll move up the other part. Same distance, so I'll right click there, and then maybe we take this part out. So and right click. So keep in mind the only other couple of things we're missing is the flashlight bulb, the bulb for the flashlight, and we're missing the battery. So if you really wanted, you could try and find some models of those and put them in, but for now this will be enough. Bring that down, and I'll right click. Right click. So this looks good. So I'm going to hit check. You can see my exploded view. So now, inside this configuration manager, under this, you'll have an exploded view. And so you can right click this and you can collapse it, so you can go work on it again, or you can explode it. And when you collapse it, you could, if you want to make a movie, you could always animate the explode. My computer is a little bit slow since I'm also recording. Trust me, yours will go a little better than mine. Mine usually goes pretty well, except for it's also trying to record all this. But so it's slowly going to bring all your parts apart and together. Right? So start it over again. Just play. So see, it pulls it up, pulls it up, pulls it out, pulls it down, pulls it down. Right, so that looks good. And if you collapse it, you can let's explode it. Explode it. Maybe you want to show it. You can animate the collapse. So maybe you want to show the different parts separate, and you want to show them going together. Right now, it's trying to calculate all the graphics for it. So change the speeds. Anything like that. Alright, so let's take it back again, and then I'm just going to hit play. So let's show. Still struggling a little bit, but I think you get the idea about the animating these portions. So I'll leave it exploded. Go back to here. And you can even make drawings of this. So you can always come in and make a drawing from part or assembly. So select a drawing. Choose the different styles that you want. So now it's asking you for the different. If you come over here, it's asking you for the different types of views. So you can now choose the isometric exploded view if you want. And bring it over. So you can always. So because you have the exploded view, it'll allow you to show that, which could be helpful for the showing someone how things go together. Okay, well, I think that's all I wanted to show, and so hopefully you can follow this now to get to a portion where this is all together. You can always right click over here or right click on here too if you want to collapse it. You don't need to go all the way back into the tree. And you can also, of course, make your head solid again if you want. But you can see how it's harder to see what's going on now. But okay, well, good luck following this video, putting your flashlight assembly together. So this last little bit, I want to show you how you can actually add some lines to show how the different pieces go together. You can also, if you want, you can come in and edit the explode steps. Maybe if we're missing one, for example, like right now we don't have the window lifted up, so maybe we want to lift the window up. Right, so we can add this explode step explode step in if we want. The other thing we can also do is we can right click on this and you'll see the smart explode lines. So these smart explode lines will detect how the different parts were moved. And right now we have bounding box center, so you can see it does a bounding box of this base and the middle, and it says, okay, well initially that point was here, where does that point move? So that's how it draws the line. So we can hit check, and you'll see it adds the lines showing how the different parts will be end up putting together. So save our flashlight assembly, and we do something similar. So we come in here, and actually we're going to go File, Make Drawing from Assembly, drawing. So this will load. So again, we can choose our default template. Right now it's not seeing any specified templates that I had, but let's just go with one that's pretty close, the A4 landscape. So you could of course bring in your whatever template that you want to use, even if you have your own custom ones. And if you scroll down, you can have the choice for isometric, bottom isometric, or isometric exploded, right? And so let's drag the isometric exploded on here. All right, and maybe we want it a little bit bigger, so we won't use the sheet scale, but we'll use a custom scale, right? Let's try 1:1, see if that's too big. Oh, it doesn't look too big. If you ever go on the edges here, whether they're blue or orange, you can come and drag your different views around. Here we can change whether we want, inside or outside. Sometimes this view, when it comes in, might not be the right isometric view. So sometimes what I have to do, sometimes what you have to do, so let's say you didn't have the angle where you saw this part coming out. So I'm going to make it the wrong view. So let's say you brought it in and it wasn't this view, but it was, zoom out a little bit here. So let's say it came in and it was this view right here. What I would do then, so this would be like came in as this isometric view. What I would do then is I would, on this initial view, I would try different fronts like this. So I might try, let's try the right side, right? And I would do it until I got a view that I liked. I don't like this one because they're in a row. So maybe I'll do this one. I don't like that. I don't like that one. I don't really like that one. Let's try this one. Right, and so I'd go and I'd do one of these until I found the one I liked. So I found this. When I put this here, I get this right view, right? And you can always take this view and delete that view and just bring this view down. So I was lucky in that when I brought it in, it happened to be the isometric view that I wanted. But if you don't, you can kind of go and kind of have a workaround. So the last part is, and I showed this in the other drawing videos, but I'll show it again. If you go to annotations, you can actually also add a bill of materials. So if we go into the bill of materials, we can say we want a bill of materials for these right here, all the parts in this assembly. And so there's different things you can change, but usually I'll just bring in the standard one. So now you can come in, you can fill in the description. Sometimes when you double click, it'll ask you if you want to override the base value, right? It's because it's linked to something. So I'm gonna hit cancel because I don't even really need the description. Let's say I don't really need the description. I can select with the left click, select it all, and then right click can delete the whole column, right? So I can see now I have a list of all the parts that I need to make this, right? And maybe these part numbers don't make any sense. So it says, do you want to break this link to the actual part name? I'll say, yeah, I want to. So maybe this part right here is 10-32 screw. This one right here is, it's going to ask me this again. This is, 32 screw. Just call this this is the short one, because again, if I remember, I showed you how to bring it in from the design library in SolidWorks, and then also from McMaster. So if we use the same one, which we should have, then it'll be the same one here. I mean, let's try something fun. Let's see if we switch these out. See if maybe we want to do just all the SolidWorks ones. So I'm just gonna take this one and say, you know what, I didn't actually want this part. I'm gonna first undo my exploded view. So I'm gonna collapse everything. Right, I'm gonna come back in here and select this binding head screw. And I'm gonna delete it. It's gonna get kind of confused about some things. It's gonna be missing something, and I'm gonna select this socket, this screw right here, and I'm going to click on Control C, click in the window, hit Control V, so I have a second one. All right, so there's one inside of there that it's kind of hard to grab, but if I rotate it around, I could find it. And I'm going to do the same thing where I'm just going to mate this all in here. And so I'm going to mate this face to this face. So that's a little bit too low, right? So this right face is not. This face is not right. I need to select. It's not letting me select the clear glass. So sometimes when things are transparent, it doesn't like to select the transparent edge. So let's see here if we can, this window. Let's take this window. So before it was a little bit happier doing this, so let's see if we can go into the window. Let's make it not transparent for now. And then we can mate this, right? So now it's going to let us select this top plane. Let's select this bottom plane. So we'll put those two together. Check. I have to move this off so that I can select something cylindrical. I guess I could have selected that before. This and this we want to be concentric. Right. And then I can take my window again, I can right click on it, and I come up and make that transparent again. So it was acrylic. And then I can look at my exploded view. Let's see how this looks explode. So it's missing this one now, right? So we're going to come back in and we're going to edit this feature. We're going to say, you know what, actually, we wanted this one to be exploded too, like this other one. Check. And then let's do these edit smart explode lines. So it's missing this component, right? So now it gets that component. So we have all these. So if we save these, let's see how smart SolidWorks is. Come back into our window here. And so here you can see we have our 1032 set screw. And since we brought in the same bolts this time, you can see this is the McMaster part number. We can call this the 1032 handhead screw, and you can see it has two of them now. The other nice part that you can do is you can auto balloon this whole thing. So we can auto balloon it. So right now it puts all these on an anchor on the same line. So if we select one of them, it's going to see if we want to just move the whole anchor around. We can, for each one of these, we can change, where it points if we want. Maybe that one's better. This one's better. This one maybe wants to point a little bit more here. This one will point a little more here. Number 6 can go over here. So those look good. We still don't have a balloon on this one, so maybe we'll want a balloon here. Let's put it in line with the other one. So we're gonna balloon here, or snap it to that anchor. So you can see we have 2 6s, right? 2 number 6s. We have the set screw. As you can see, this kind of looks like a drawing that you'd get when you got all the pieces together, right? So so this is a nice way to show how to assemble how something all goes together. You don't necessarily need the hidden lines, right? We can just do a little bit simpler. And so if you want to print this out, I'll usually save this as a PDF. Put it on my desktop. Desktop, flashlight assembly. Right, and so this is something we can we can print out. Obviously, we want to fill out our title block, and we can make a title block more specific to us. This is a nice way to show an assembly. All right, so good luck putting all of this together.